Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, you'll learn how to creating here and calories burn prediction applications using FastAPI and machine learning. So in order to building here the application for the calories burn predictions, you're going to using the dataset from the Kaggle that's called calories burning dataset. This is a dataset just you can go down and you can see here it having the two CSV file. One is the calories.csv, it's just having the user ID and the calories, and in the case of exercise, it having the 8 features columns. So when you're using this data set into building here our applications, just go on here the Kaggles and sign up with your Gmail account and click on download button. Let us start by importing here some of the important library so that we can creating here the machine learning model as well as we can do some data analysis on that. So let's importing here the pandas as PD. Then I'm going to importing here the numpy as np. Then I'm going to importing here the matplotlib plot as plt. Then I'm going to importing here the cborn as sns. That is cborn as sns. So using pandas library, you can load the data from a directory as well as you can do the data visualizations. Using numpy, you can do the matrix types of multiplications using that. And using matplotlib, we can do the data visualization in a manner way. And cborn is the same library just like the matplotlib because cborn is working based on the matplotlib library. So shift enter. So you're loading this one, and after that, what I can do, you're also going to importing here the scikit-learn so that we can also using here some of the important features like we can load in the machine learning model as well as we can loading here the standard scalar for the data preprocessing. So let's import it first, and after that, I'm going to load in the data set from the directory. So let's say from scikit-learn dot preprocessing. So you can also use the tab key from your keyboard to getting the auto suggestions. So let's import here the standard scalar. Let's say standard scalar. The standard scalar is applied in the numerical data, and we can also importing the ordinal encoder so that you can also apply it in our categorical data so that you can convert them into the numerical format so that we don't need to using the map methods. So now let's say from scikit-learn dot matrix. So matrix, I'm going to importing here the R2 score matrix. So let's say R2 score. So you can use the same tab key from the keyboard and it will give me the auto suggestions. So let's say score aja beta niare agya score. Then also we're going to importing here the mean absolute error. Let's say mean absolute errors. And then from sklearn dot model selections, we're going to importing here the cross validation score. So let's say cross validation score, as well as we're going to importing here the fold, number of fold, that how many fold you're going to using that in order to training your data. And then our train, test, and split, because in order to creating here any machine learning model, we need to divide our data set into training part and the testing part. In some general cases, we are taking the 80% for the training and 20% for the testing cases. Now let's say from scikit-learn dot linear model. So let's say linear model, I'm going to importing here the linear regressions because this is one kind of regression problem that you can see in the data sets, and also it's a supervised machine learning problem. So let's say from scikit-learn dot ensemble, I'm going to importing here the random forest. Let's say random forest, it should be random forest regressor problem. So let's say random forest regressor. So if you are to making this linear regression from a sketch or the random forest from a sketch, you can also follow my video that is available in YouTube channels. So without using the scikit-learn module, you can also building this out. Okay. So because you already have this one, so that's why I'm going to using these ones. Now from the XGB boast, let's say XG boast, I'm going to importing here the XGB regressor. Let's say XGB regressors. And after that, we're simply going to importing the pipelines. Let's say from scikit-learn dot pipeline. So pipeline, I'm going to importing here the pipeline. So I'm going to creating here a pipeline of the pre-processing data with our machine learning model. So that's why importing here the pipeline, as well as we're going to importing here the column transformer. Let's say sklearn dot compose. I'm going to importing here the column transformer so that you can transform the data inner to using the column transformers. Now finally, I'm going to importing here the pkl so that you can save our model as well as we can load it to our applications. Now I'm going to loading here my data sets. Let's say pd.read_csv. And inside that, I have to give it the path of them. Now let's have a look the dataset first. Then after that, you're going to see that what actually happening inside this data, because it has the two data sets. So we have the two data sets. One is called calories, which are having the user ID as well as the calories. And another data set is nothing but called the exercise, which can also have the user ID, gender, ages, height, weight, durations, heart rate, and the body temperatures. That's mean in the two of the data set, it having one single column, which is same. It's called the user ID. Now, based on this user ID, we can concurrent the data set or we can merge the data sets. Now let's go on the Jupyter notebook and try to do the coding part here. So now let's give the file path. So it should be the calories.csv. So we can give it to you. Let's say calories.csv. And now let's assign it to a variable called calories. Let's say calories. And after that, we're simply going to loading here our next one. Let's call exercise.csv. Let's say size.csv. And then this should be the exercise. Okay, you can give it here any kind of name. So let's say exercise. That's it. So our data set is loaded. So you can also checking this out. You can using here calories, this calories dot head, and then you can see the data sets. Okay, it's not defined. It should be the calories, right? COL, spelling mistake. So you can see here the data sets. It's having the user ID and the calories. Now you can see here the exercise as well. So let's say exercise dot head, and you can see here it having the 1, 2, 3, 4, 5, 6, 7, 8. It have the 8 features columns, and both of the dataset having one similar thing. That's nothing but called the user ID. I mean, you can also take it as a primary key as well for the tables. But in here, we see that we have one common columns, which one is called user ID. Now, based on this user ID, we can join them, or we can concatenate them, or we can merge them. So let's start using here the pd.merge. So let's take in some shell merge, and let's say pd.merge, and inside that I'm going to give it here the calories, and as well as I'm going to give it here the exercise. It should be okay, it should be the exercise, right? Let's see the spelling. Okay, exercise. So this one, and then we're simply going to give it here one on. I mean, using the primary key of the user ID, we're going to join them. That's a user ID, because in both of the dataset, they just having one columns is matched. That's called user ID. Now let's assign it to a variable called data, and then after that we can see the data. Let's say data.head, and then you can see here that's our data. Now it's joined. So you can check the shape of the data. Let's say data.shape. So this is the shape how it look like. It having the ninth columns, because it's also added here the calories, as well as it having the 15,000 row. I mean 15,000 data. So you can check the data informations. I mean information regarding the data. Let's say data.info, and here you can get some information in your data, just like how many column you have, is there any missing middle or not, I mean not null count, as well as the data type. And if I see the data type, it's just having on objects, which is nothing but called the genders, and rest of them is nothing but integer or the floating point numbers. So you can also see on here data type floating point 64 is nothing but 6. I mean 6 number of column having the floating 64, and 2 column is nothing but in 64, and rest of them column is nothing but the objects. Cool. So you can also see the descriptive analysis of the data. So what I can do, you can using your data.describe. So data.describe, and then you can simply go into shift enter, or you can also click these buttons, and you can see that it have the count, how many count it have, the mean, standard deviations, the minimum, 25% percentile, 50% percentile, 75% percentile, as well as the maximum below. So using this percentile, you can also counting here the outlier. In the previous project, I mean 62 projects, we actually discuss about that, how can you remove the outlier from the data. Okay, now let's checking here, is there a NaN value or not? And we generally see that you don't have any NaN value, because you see that our data shape is nothing but 50,000, 9. That's mean it maybe has the 15,000 of data, but we don't see any not null count on here. That's mean I don't think that you don't have any null value, but for the assumption we can check this out. Let's say data dot is null dot sum. So you can say that let's see dot sum. Oh, but some, why this 0 is coming, I don't know why. So you can see that you don't have any NaN value, but it maybe have some duplicate value as well. So we'll also checking this out, because duplicate value actually occurs some kind of errors, or occurs some kind of a pattern error, so that our machine learning model cannot unable to predict it correctly. So we'll also remove the duplicate value from here. Let's say duplicate it. So it should be duplicated, and then you can say that, let's say sum, or you can say the sum. So sum is nothing but 0, or you can also using here the any. So the any nothing but give you one boolean value, true or false, and you can see it's nothing but a false. That's when you don't have any duplicate value. Now let's try to do some data visualization. So we can taking one here, let's say data visualization, let's say visualization. Just have a look about the data, how it will look like. So you can give it here, or you can give it the headings. So okay, and you can shift enters. Now you can using here the SNS, and you already import it. Import cborn as SNS. So let's using this out. So first I'm going to setting it here. Let's say SNS.sat, and then after that I'm going to first do the count plot of the gender column, because count plot is nothing but counting the value in your data, I mean in your columns. So in our cases, gender is nothing but one object types of column, I mean it's string types of columns. So it maybe have some unique value, but in rest of the cases it may be having some contiguous value. So we can simply go into counting the using the count plot in order to see the count if the data is imbalanced or not. So let's say data, and then you're simply going to give it to the gender. Let's say genders. So, and you can see that data is quietly perfect, and 50-50 is nothing but the male and the females. That's when data is balanced in terms of genders. So we can also checking this out in the case of age column. So age is nothing but also one object types of things. It may be, sorry, not object types of things. Actually, age is nothing but one numerical types of things. So what I can do, we can see the distribution of that. If the distribution of the age is correct, that's mean we don't have any problem in our data. So we can simply going to do the displot. So let's say sns dot displot. So we can pass it here data, and let's say age, and you can see our data how it actually look like. Okay, so you see that most of the value is actually rises between the 20 to 30. Most of the values on here, I mean most of the ages. So we can also see that the plot is correctly it correct at well. So we don't see anything else on here. You can see if I draw this like that, so it's also normal distributed kind of things. So now let's try to also plotting something. uh okay, issue dist plot. I don't know, I actually I'm a little confused at where the graph is actually why are this distribution plot actually coming. Okay, so that's a density plot you can see, and you can see our density of the ages. In first time actually confused at why not this graph is painted like that. Okay, it's just plotting the bar plot, but it will now plotting here the density curve as well. So in the y-axis we have so in the axis we have these ones. So y-axis we have the density, and the axis we have the ages. Okay, number of ages. So you can see that the age is correct at well, not so bad in case of data. So now let's try to plotting it out for the height as well, because you also having column called the heights. Okay, so we can simply going to using here, let's say sns dot dsplot. So now let's see the data, and from here we have the heights. Let's say heights. So this is how it look like, and this is look like the normal distributions, right? Quite straightforward normal distribution. We don't need to do anything else on here. But yes, we can also apply here the standard scale in these cases. I mean the normalization techniques. So you can using here the weight as well. So you can copy this out. So you can give it here the weight. Otherwise, you can creating here functions in order to plotting this out, the density plot. Okay. So in kind of weight, the same thing is normal distributed. It don't have any problems. But for the themselves, we can also do the standard scalars, so that our machine learning model can get some pattern on that. Okay, that's it. So now what I can do, we are simply going to finding the correlation to the data sets. Okay, because it's important to select in the features, the best feature from here. So let's see. Let's find the correlations between our data sets. So the correlation, we have the two types of correlation. One is called the positive correlations, another one is called the negative correlations. So let's say data.core. So let's say data.core. And using this method, you can getting here the correlation matrix. Shift enter. So you can see the correlation matrix, how it look like, but it not it took it quite local the mismatch types. So it's better you can plotting this out. So you can plotting this out using the C1 library using the heat map. So let's assign it to a variable. Let's call correlation. So I hope so it should be the R, 2R. Okay. Now it's executed. So you can now taking one figure. Let's say plt dot figure, and you can simply going to pass it to the fixed size and 20 comma tens. And now let's say sns dot heat map, and inside this heat map we can simply going to passing here the correlations, and you can give it here some properties like the CBER, the score, the FMTB or annotations. You can give it here any of the thing you can give it to here. If I running this out just here, you can see it visibles, it plotted, but you cannot see the the correlation matrix correctly. So that's going to give it some kind of property. Let's give it here CBER is equal to true, so that you can see the bird. Now let's give the score. So a score, let's make it as a true. Now let's give it to the FMT, so that you can also see here, see the number in the case of floating point number. If I see these correlations, just little bit, and so let's say correlation, and you can see that it having some minus value of the long. Okay, so you can taking here the first 0.01 from here. So you can keep it here. Let's say up to point 1. So let's say up to point 1 half, 14 point number, and after that you can give it here the anode. So anode, so that it will give me some kind of annotations. True. So it should be true. And then you can also give it here the size of that. And now let's give it a C map. So color map. So we can give it here, let's say blues. I mean blue color. Now let's see. So you can see here how it actually look like. So in the diagonal is nothing but 1, because the highly correlated to each of the columns, each column to each columns. I mean user ID to user ID. Obviously it's a high correlated. So the value is nothing but 1. But in all of the cases is negatively correlated, you can see. And in here, the calories to the durations is highly correlated. So you can also dropping one column from here, but calories is nothing but our target column. Okay, so you cannot actually dropping this out. And if the target column is correlated to each of the columns, that means the target column is highly correlated to these columns. That is important. But in the case of calories, the heart rate it's also important. The body temperature is also important. That's mean the durations, the heart rate, and the body temperature is very important in case of the calories. And also you see that 0.2% is nothing but for the ages. I mean age, durations, heart type, heart rate, sorry, not heart type, and body temperature is highly correlated to the target classes. I mean calories. Okay, so you can also see some assumptions on here. So you can also do the feature engineering on here, but I don't think that it's not needed, because it's just having few columns, 9 column. If I have the 20, 30 column, then you can go for the feature engineering, right? Now we're simply going to divide our data set into dependent and independent features. It will be better for that. Okay, so now let's say x. So let's say x is equal to data dot drop. I mean, except the user ID and the calories, we simply taking all of the columns from the x, because we don't need the user ID. We don't need the calories, because this is an supervised machine learning problem. So that's why I can keep it here as the target columns. So we can, let's say columns. So let's say user ID. Let's say user underscore ID, and then you can also give it to the calories. Let's say calories. Okay, make sure spelling is correct. And then y is equal to, so let's say y is equal to data of the calories. Okay, let's say calories. Okay, that's it. Now we have the x and y. Now you can simply go into using the train, test, and split, because you already imported, right? So let's use it here. Let's say train test split, and you can pass it to the x and y, and then I need to give it to the test size. So let's say 0.2, and I will talk about that why you need to give it to the test size at the 20%. I mean 20% of the data it's passing to the testing size, and 80% data is going to the training side, so that our model can learn as well as testing with the unseen data. Now let's say random state. So it's a 52. You can also checking this out. Okay, the previous video. How can I choose the random state? So now let's say x text. Okay, it should be x string. Sorry, and the x text, the y train, and the y test. Simple. Now, what I can do now, just because of we just having one object columns, I mean the objects, I mean string, you can set the category columns. So we can simply going to using here the ordinal encoder, this ordinal encoder, and rest of them I'm going to using here the standard scalar because we don't need to apply here any pre-processing on that. So standard scalar is nothing but called the normalizations, because if I see the distributions, distribution is okay, but in case of ages, it's not normal distributed. But in case of age, sorry, in case of height, sorry, so it's look like the normal distribution, but it's better you can pass it to the standard scalars. So what I can do is simply going to, let's say, data dot columns, so that you can see the columns. Okay, that's our columns. Now we can simply going to creating here one column transformers. So let's say column transformers. So in column transformer you can pass in here the many of the data or many of the standard scalars or transformer technique. So the transformation technique actually. So now let's give it to the transformer first. So transformers, so we're going to be using here the two transformers. One is nothing but for the ordinal, it's called the, for the categorical value, let's say ordinal. Okay, it should be ordinal, sorry, not ordinal. And then you can simply going to using here the ordinal encoder, and you can simply going to give it to the genders. Let's say give it to the genders, because gender is nothing but and categorical columns. So you can also mapping this out, but it's better you can using the column transformer, no technique. Okay, so now let's give it here the num, I mean the number, and then in the case of number you're going to apply here the normalizations, I mean standard scalars. And then we can using here all the columns just like the age, the height, weight, durations, heartbeat, and the body temperatures. You can copy this out and you're going to paste it to here. So let's try to take it. Okay, and then now you need to give it here a reminder. So let's say reminder is nothing but the pass through. Let's pass through. Okay, and this is nothing but my preprocessor. Let's say preprocessor. Okay, और ज़्यादा हो गया क्या? नहीं, preprocessor. Okay, fine. So now what I can do is simply going to run this out. Cool. So now let's get into the pipeline. So you already imported the pipeline, right? So this one. So I'm just going to using this ASGI regressors. So it's your homework to do it the random forest and the linear regressions, right? So let's do it and dedicating here pipeline. So let's say pipeline. I just using here the ASGI classifier again, ASGI regressor, sorry. So your job is to doing with the rest of the machine learning algorithm. I already imported here. Now using here the preprocessor, let's say preprocessor, and then I am simply going to give it to the preprocessor. So preprocessor spelling should be correct. Preprocessor. Okay. So then to give it to the models. So let's give it to the model. So we can simply going to use it here. So let's say model, and then I'm going to using here this ASGI regressors. So not like that, it should be capital ASGI regressors. And then I'm simply going to store it inside a variable called pipeline. So let's say pipeline. This is how you can creating here the pipeline for the machine learning algorithms. So any error, two position argument taken, but 3 was given. Anything wrong? So we have the pipeline. Okay, you have to keep it here on one list. So because we have the multiple number of data, right? The preprocessor in the model, that's why. So now let's see. Okay, it's executed. Now let's say feed it our data. I mean feed it our training data. So let's say pipeline dot fit, and then you can using here's x train and then y train. Now we fit it. You can see that ordinary encoder, standard scalar, the pass through, and it pass into these XZB regressors. So this is our machine learning model, right? You can see ordinal. It has the gender, the number, it has the age, height, weight, durations, heart rate, body temperatures, and in the case of remainder, it's nothing but the pass through. Okay, just pass through here. Or you can also give it to some kind of parameter in this reminder as well. So now what I can do is simply going to predict it. Let's say pipeline dot predict, and then you can give it here the x test, and it should be the y predict. Let's say y predict, and then you're simply going to calculate the R2 score. Let's say R2 score, and then you give it here this x test and y prediction. Let's say y predictions, and here you go. Okay, we got in here 99% of the R2 score. I mean R score. That's mean it's a best fit, because if the value is nothing but the R2 score value is range between the 0 to 1. If the value is closing to the 1, that's mean it's a best fit. I mean model is correctly predicted. Now let's also calculate here the mean absolute error, and then you can give it to the y test and the y predictions. It's also good, 1.5, not so bad. Now you're simply going to apply here the scaffold. Okay, I mean let's try to do the cross validations. You already imported the scaffold, so let's say apply it here. So we can simply going to initialize the scaffold. Okay, I mean just you're going to replacing here the training and testing data and try to use it again for the predictions. Okay, so let's say number of split. So let's give it a 5, and let's give it a shuffle if your data is shuffle or not. Let's give it here the true, and then the random state is starting with the 42, and it should be the scaffold. Let's say scaffold is this one, and after that you're simply going to using this cross validation score, and then you're going to passing in the pipeline, as well as you're going to passing in the x and the y, and CB is nothing but the scaffold cross validations scaffold that you initialize, and scoring is nothing but based on the R2 score. So it's the R2 score, and this is nothing but my CB result. Let's say CB results. Now you can shift enter, and then you can calculate the CB results dot mean, and this is nothing but my cross validation score, because we have the 5 split, and from the 5 split we're taking the mean of that, and this is the mean value. I mean this is nothing but our R2 score. It's nothing but 0.9987, and same thing on here. Okay, but it quite improved because it's 0.99876, but it's 875 like that. Okay, quite good. Now you can simply going to store it in the form of pickle. So let's say open, and now let's say pipeline dot pickle, and then to give it here the mode, let's say wb as f, and then we can simply going to pickle dot dump, and then you can give it the pipeline dot and comma f. Okay, so you can give it here any kind of name, pipeline or pipeline model. Let's give it a pipeline model so that it look like code. So shift enter, and it will store it inside our folder. Now what I can do is simply going to creating here one web applications using the FastAPI. You can also using the Flux, Streamlit, Django, or the React.js. Now let's go on the VS Code and try to implement this out. So now it's time to creating here our web applications, and for this case I'm going to using the FastAPI. And also you can see here we have our model file, pipeline underscore model.pickle file, and I'm going to using this one. So this is the code written in app.pl file. So it's better you can run this application first. And this is the server side code, and inside our template folder we have the front end part. So now it's the link is appeared. Now simply going to clicking on here. Let's click on follow link. So our application is loaded. That's our application is called calories burn predictions. So in here you can see you can selecting the gender, as well as it having some input text box. So here you can give it here the value. Now let's give it here some kind of value. Let's say age is nothing but, let's say, 68, and height in a centimeter, let's say 190, quite tall, and weight in a kg, let's say 94 kgs. And now let's say duration in minute, let's say 29 durations. And now let's say heart rate, let's say 105. And body temperature, let's give it in the kind of Celsius, let's give it to the 14. And now click on predict, and this is the calories burned. So 23.14496 kilocalorie. So you can click on go back. So it's nothing but how an exercise, and you can give it here some kind of value based on that, and it will give it here the response. I mean, how many calories actually burned. Okay. So you can also creating here your Android application as well. Now let's go on our application and try to understand that what actually happening on here. So let's close it. So first what I can do, we having one template folder, and inside this template folder we having our index.html file. So if I see this index.html file is nothing but one UI files, you can see that it's just having a title called calories burn. And after that, you also added here the tailwind CSS because it's easy to use. And using tailwind CSS, you can creating here some interactive UI. And then we have the body tag, and so this body tag we having one is to tag, heading tag, which is having a heading called calories burn predictions that you see in the application, that you can see calories burn predictions. And after that, we have in from, and action is nothing but the predict is the actions, and method is the post methods. And we just give it to something called a space on that in the y-axis, so you can see the space in the y-axis. And after that, you're creating here a div. So in the div, you're having the genders as the labels, and also you're having some drop down menu. So where you can selecting here the male and the female, and the value is nothing but the male, and the value is nothing but the females. And also creating here another div, and inside this div, you're having the age, and then you give it here some kind of staff, so that you can also increase it. You can see step. So if I clicking on here, you can see it will increase this. So it's better you can give it here the one in the case of step. So let's give it here the one, and if I save it, and if I go on here, and if I reload the applications, then it will start it from the one. Okay, like that. Okay, not right now because you need to also stop the server and restart the server again. Then it will actually work. Okay, so let's close it. And then we have in the for the height, you can give it here any kind of height. It started from the 0.1, or you can also give it here the ones. And in the case of this div, it has the weight, and also in the case of this div, you have the durations, and in the case of div, it has the heart rate. A step is nothing but 0.1. You can also give it to here. You can see you can increase it. And then we have in the body temperatures. Okay, and as well as we having a button, and button type is nothing but submit. So why actually give it here as a 0.1? Because in the case of height, it may be the 0.1, 0.2. If we need to changing this out, we can use in a step. But in the case of ages, it's not the point. Okay, so you have it the from, and the from method is nothing but the predict method. So how you're getting here the values from this from, and to redirect to the another pages is called the results. And inside this result, we having same thing. Just we having one ginger template which is coming from our app.py file. I mean our server side file. Then you can simply go printing this out. Okay. Now it's better you can go on here. So first we actually imported the first API, and from the first API we import the first API, the from, request, and the depends. And for the first API, the templating, we importing the Jinja 2 templating, so that you can also calling the HTML file from this template folder directly. Then import the pkr, so that you can also loading here our pipeline underscore model file, and also import the pandas as PD. So first we're creating here our applications app equal to first API, and after that we are going to loading our machine learning model. So this is how you can load it with open pipeline model pipeline underscore model.pkl and rb, and you're simply going to give it to the app, and we have our pipeline. So I can also typing this out, but I don't think that it's not needed. It's quite time consuming to creating here this HTML file, this app.py file. Okay. So then you can do setting up the template directory. We simply going to give it to you the direct format, and we're already creating here one initial route. For that, you can see def is the initial route. If I just hitting this out, it will just give it here the index.html file. So and now you're simply going to calling here our methods. So how and the users fill up with the value call ages, height, weight, durations, everything. Then we're simply going to calling this functions called the predict. So you're creating here a functions called predict, and to taking a request that you already imported, and we're simply going to taking the data from the users, I mean from the from, using this from, so dot 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 dot, I mean taking all the value from here, age, height, weight, duration, heartbeat, temperatures, and based on that you're creating here one data frame. Okay, see gender, age, height. If I go on here inside this index.html file, you can see here the name is same as it is. You can name is same as it is. Gender, age, height, weight, durations, heart rate, body temperatures. Same thing on here in the name conventions. You can name convention, age, height, weight. Make sure that your spelling, your case is also correct, because it's quite case sensitive. And then you simply going to using his pipeline and try to give it some sample data, and after that you're getting some results. Now you're going to pass in this result to the ginger template, and inside this result it will taken. And now if I go inside this result.html file, because it passing to the result.html, it will take in the request as well as the calories in the from results. So now it's taking this out in here, you can see in here, and then you can simply go to painting these calories on here. And after that horn actually predict it, then we got in here the result on this. Okay, so you can also testing this out in actually you can testing this out in the Postman as well, because this is an API. So if I opening here my Postman, so let's say Postman, now let's see. So if I open the Postman, then you can also using this initial route, it will opening in 800 localhost of 80. Now let's see in the Postman. So किधर गया Postman, opening हो रहा है, तो provide करो, and our server is also still running. So you can go on here. It's still open. It's taking few time actually, because recording is actually happening. Server is also running in the Pythons. That's why. Okay. So well, so right now we are in the Postman. So we can give it here the URL. So let's give it here localhost. So we can using this one, and instead of the 3000 you can just give it here the 8000s. And if I see the code, that's the code. So you have the get method, I mean initial route. So if I click on send, so it will give it here the response of the index.html file. So we also getting the response from here index.html file. So if I go the raw, this is a raw file, and if I go inside the preview, then you have the application directly how it look like. So tailwind chase is not working in this case of Postman, but yet we got in here some kind of response. So but we don't give it the post request, because in the case of a post request for the predict, we just take in the input from the from, I mean from the users, and then you can simply predict it. Okay, so if you are just getting here in the case of first API version, then you can also testing the predict method in the Postman. So now what I can do, it's better you can run the application again and try to see it at the last. Okay, so let's click on here. Yeah, it's still running. Let's close this out, and now let's click on here to running the applications, and after that let's testing this out with the new data. So let's click on the link, the follow link. It will opening here in the Brave. Now let's selecting here the female this time. Now let's give it to the age, let's give it here 20, and give it to the height, let's say 166.0, and weight, let's say give it here 60, because it's just 20 years here girls, that's why. And duration, let's say 14 minutes, and heart rate, let's say 94, and body temperature, let's say 14.3. And now let's see, click and predict, and this is the calories burned from this girl. Okay, 65.21089 kilocalorie. Okay, so this is how the application actually work. You can also implement this full application from the Android as well. So thank you, and namaste, and bye bye.